All right. Hello. Um, I am just going to talk for a little bit. Somebody in the chat tell me that everything's working and you can hear me. And if so, I'll get going. All right. So there's a long delay, so that's why I'm sitting here for a while. This is my first ever attempt at live streaming, and my goal at this YouTube endeavor, I don't really have any YouTube dreams or anything like that, but I just want to get slightly better than last time. And so, anyways, here I am. I have a lot to go over, and I have a lot of show and tell to do. I have. I'll just kind of show this up so we got a lot of. Oh, can't drive the mouse. I got a lot of different inventor whatnots that I can run through. And anyways, so I got lots of visuals that we can use to talk through the problems. I'm a teacher, and I teach computer science. And oh, where's my mouse? Sorry. One of the things that so I teach computer science, and so this is the what do you call it? It's like Notepad, but you can compile programs on here. So I've started like writing notes whenever I do class lectures and stuff for the kids. So this is my comfort zone. So I'm going to go through this and type out some notes. Or actually, I typed out some notes based on the questions I got from the MonoRail video. And so I went through all 900 some odd comments, and I found the main comments and try to condense them out to these topics. So I'm going to go through these and hopefully get you guys some answers, and then afterwards I'll go look at the chat and see if there's any other questions. And anyways, let's do this. So first thing is scalability. So obviously the MonoRail is scalable. Obviously, you can, but I would like to point out that it's not as scalable as you would want it to be. You can scale it along the rail dimension easily, but as arms get longer and longer, the deflection of the arms is a function of the length to the third power, I believe. So if I double the length, it's going to be 8, and I don't change anything else. Everything else remains constant. If I double the length of the arms, then everything will be 8 times squishier, which is not great. So you'd have to scale up the cross section and stuff like this. And anyways, you can scale up, but going super large with this is going to be hard. There aren't that many large triptyrons in the world, and there's a reason for that. It's just really hard to get that plane constraint that each of the arms have. All right, so drive options would be the next thing. All right, let me pull up this. Well, this one's a good one. This one's the DuoRail, which is I'm playing with this idea of doing 2 rails, but I already have another idea, so I'll get to that one. But so how would I drive this? Well, as drawn here, there are steppers here that drive belts that go through the rail. So there's one on each side. You can actually see here that the belts go through the extrusion. And I don't have it shown here, but I'd put a little piece of plastic underneath this, and it would reach down and grab onto the belt. The belt would not be a continuous loop. It would have ends, and you could bring it out and use that for tensioning, yada, yada, yada. So that's how I'm planning on driving this. I know there's like a million different ways to drive this. Belts and stepper motors are very easy, cheap, fast, proven. So I'm cranking out a prototype. I'm going to keep it all pretty basic. What are some other options though? You can do a rack and pinion, of course. One of my favorite ones is you can have a static screw, and then you could have the stepper with the nut in the inside of the stepper, and it could turn and move it along the static screw. That way you can actually have one screw and multiple steppers along that, so you can have a shared axis. That's really cool. One of my favorite ways, and a lot of people mention this in the comments, is to have a linear electromagnetic motor. I don't know exactly the right name, but basically it's like a stepper motor, but you rip it out and you put it flat on the rail. And so you can change the fields and stuff and move over in a linear way based interacting with the rail directly. Anyways, no shortage of ways to drive it. I'm just going to leave that as like not something I need to like dive in for the prototype. So. All right. So angles. I'll just say real quick that the angles are, I'll say, shoot, sorry, give me a second. All right. I'll say that angles, I don't know what angles are the best. That's a very open question. I would have to possibly do some hardcore simulations and see where I get collisions, how I can maximize my build volume. So yeah, right now in the MonoRail video, I think I have the outside ones at 45 degrees, and then the middle one, I have it slanted at 30 degrees. So the angles don't really matter. What matters is that you have 3 planes that don't all intersect at a line. You need to intersect at a point. So if you start with one plane, you need to tilt from that one, and you can't tilt in the same angle. You'd have to the third one would have to tilt in some other angle. All right, firmware. Firmware is a done deal. I'm going to use. I actually have it right here. I'm going to use a Duet 3 Mini, fantastic controller, and it runs RepRap firmware, and they've already built in some amazing things. One thing they've built in is arbitrary matrix transformations, so you can. So, anyways, the kinematics on this is almost a core XY kinematics, and it can be expressed very easily with a matrix, and all of that can be put into firmware. I'm not even worried about that. I haven't looked at it. I know that that's going to be a slam dunk. Okay, so second rail for support. So a lot of people commented like put another rail, add some more support, and they meant that in 2 different ways. Let me go pull up Inventor again. Boom. All right. So all right. So here is here's the MonoRail, and right now I have 1 rail, and I don't have it bolted to anything, but I can bolt that to an extrusion and keep it from twisting. So that's a big concern everybody has. Like, isn't that going to twist? Yeah, like as drawn, it would be a big problem. It actually wouldn't be as big of a problem as you'd think, but might as well bolt it down to something. You bolt it to a table, an extrusion, whatnot. Some people say throw another one of these rails on there, and you won't have any problems. But these arms don't weigh very much. So this is probably about 200 grams what I have in my hands here. So there's 3 of them, so that's about 600 grams. That's starting to add up, but then the effector is going to be another 200-300 grams. There's not a whole lot of weight, and this thing doesn't get out. Anyways, the leverage, even the dynamic forces don't get too high. And these carriages, I've been told, have very low play and have torque ratings up to like about 50 foot-pounds. Anyways, way above and beyond what I would need for whatever forces I'm going to put on this. And I'm not going to put that much force on it, because I know that this is a squishy robot. The end is going to be, defined by these long arms, and the rigidity drops off the longer you get. So I'm gonna try my hardest to keep the weight down. So it's not the carriages that need to be held nice and rigid. I'm not gonna have torque problems. It's the arm rigidity that's gonna be the main problem. So those arms need to get beefed up. If anything, the rail way over engineered for what I need. So keep on back. Okay. All right, build volume. Okay, and I see in the live chat there's some questions about build volume. So just know that I'm not sticking with the monorail. As I showed in the original video, I have a different idea. But since a lot of people are curious about what its build volume is, I will go show it. I meant to model it up so you guys could actually see it, but I can kind of just talk you through it. If I look at the top of it, this rail would need to be a lot longer, and so if I have that left, let me zoom in a little bit. Okay, if that left carriage is pegged at the very end of the motion, I'd have to keep on getting closer and closer to keep it from going off the end. So from the top, you have kind of a trapezoidal build area. So once I hit the other end, then I'd have to go in again. So trapezoidal from the top, and it can reach out as long as, well, once the arms go straight, that's as far as you can reach out. And so these are 200 millimeter arms. So 400 millimeters divided by root 2, whatever that is. And that's only like when they're straight at the bottom level. As you go up in height, that's going to cause a little arc. And whenever I look at it from the right, I can go pretty high. Now I am constrained by the carriages. So once I go so high, then I get a carriage collision right there, and I can't go any higher. And as I come towards the Z, I have to go lower and lower to keep from getting the carriage collision. Let me see if I can get a good angle for this. So, anyways, basically Z is 0 close to the rail, but you don't want to print close to the rail. As you move farther away from the rail, you go up and up and up, and the Z increases quite fast because I picked like a 30-degree angle. So it's not like, it's a pretty steep incline there. So you actually have a fairly usable print area. But there's a lot of constraints on this. It's cool because you have the one rail, and I hope somebody builds one of these. But I have a modification on this that I want to try. So yeah, it works. One rail works, but it's a wonky build area. It's more than reasonable, like just getting one rail, getting that build area. The build volume to part ratio is really good. Anyways, I'm gonna stop yammering on about that. It's good. All right. Okay, curved rails. Okay, a lot of people mention curved rails. I found this interesting. Like multiple people mention this. So I'm curious if anybody wants to say in the comments what use case curved rails would have. I can think of a few, but maybe you guys have some very specific ones. The trick with a curved rail, if you just take the monorail and just make and make the rail curved, is now as the outside carriages move, if that was moving around a curve, then the angle will change at the end effector. And so you would have to make, there's a few different ways to do it, but basically you need U-joints here instead of revolute joints, and you could get the job done, or ball joints or something like this. So the constraint's going to be a little trickier. I'd have to think about that. I think U-joints, I don't think ball joints would work, U-joints, but yeah, you could do curved rails. It makes the mechanism not quite as clean. Not as clean as I would want. All right. So since it's got a lot of Simpson comments, which I love, I had watched that episode a long time ago, and I hadn't remembered how awesome it was. So I went back and rewatched it. I highly suggest it. Like the music number in there, it's just fantastic. So anyways, so quickly, applications of the monorail. I'm trying to 3D print here, and I would like to do pick and place. I would love to, just a pin plotter, laser engraver, all of that stuff. The kind of the connecting thread for all of those applications would be just a robotic platform that doesn't need to carry too much weight. If you want to do CNC milling, you could do it with this. I don't think it's the appropriate platform. You would need a very small bit, very high speed spindle, yada, yada, yada. It would have to, you could possibly do like PCB milling, but even that, I would think there'd be too much chatter. So anyways, tons of people said it won't work, which is just, anyways. So I tried to print everything for today, and I have everything ready to be bolted up. Like the prints have probably just finished minutes ago, and after this is done, I'm going to be going and bolting up some test arms and just bolt them to a board. No rails, but just solid carriage mounts, and we'll see if the end is squishy or not. If it can keep position, I can, even if it deflects quite a bit when I push down on it, but as long as it's consistent under load, I can always like set the accelerations down and I can make this work. A lot of people put comments like, hey, yeah, you won't be able to do this with any, if you turn the corner with jerk settings, it'll cause ringing. Like, I don't know, lots of complaints about like, hey, can't do this, can't do that. Like, you just set the acceleration low, set the jerk low. Like if it can keep a position, I can print with this thing. Can I print fast? No. So yeah, it's gonna work. There's a lot of triptyrons in the world. It's gonna work. Like triptyrons exist. This is basically a triptyron with some different angles, and with the the inputs are all coming from one rail. So yeah, it's a non-question for me. It's like, yeah, this will work. It's just a matter of like how much engineering I want to put into it. All right, kinematics. I'll just write down the equation right now. So if I want to go on the X, I can move all three carriages in the positive X direction. And if I want to move in the positive Y direction, then I need to move both the outside carriages in. So I need to move carriage 1 to the right, and I need to keep the middle carriage, leave it alone, and I need to move the right carriage to the left, and that would give me a positive Y move. And then if I want to move in the Z, then I need to move I think you need to move the middle carriage to the left. So that'd be a 0, -1, 0. And some of these numbers won't be 1. Some of those numbers will be, anyways, the angle will change some of these numbers, but that's the basic concept of how they need to move. And like I said, RepRap firmware will take that directly. So anyways, there you go. If you you want forward kinematics or inverse kinematics, there you go. You want forward kinematics, take the inverse of that. Huzzah, done. All right. Now it's time. We've reached the time in the program where it's time for my rant on 3D printed part design and rigidity. And so people say, hey, print it in carbon fiber, or use this material, that material, or whatnot. I don't think that's necessary for any of this. So basically, I can design the part, test it in the computer, see if it's rigid enough. If it's not, add some thickness to it. So the basic formula that I would encourage you guys all to know is how rigid is a member. How rigid? Oh my gosh. Okay. So the rigidity of a member is related to the width of this dimension, like across the arm. So I'll call that B, times the H, the height. So how tall is the arm? And take that to the third power. Okay. So if this thing's going to get loaded this way, then this height is going to determine my rigidity, is going to be the main thing that determines my rigidity. So if right now this is 25 millimeters, and if I go to 50 millimeters, it's going to increase the rigidity by a factor of 8, 2 to the third power. And so if I go from PLA, which is what I'm printing on, which by the way, of like PET, ABS, all that stuff, PLA is actually the one that has the highest Young's modulus, so it's actually going to do the best. So that's why I'm printing with PLA, and it smells good, and I have a lot of it. But if they're suggesting that I go to carbon fiber, I might increase the strength a little bit, but I could just do a humble approach and just increase the dimension, and I can increase it a lot more than getting the carbon fiber, and I save a lot of money. And the inside of these parts are all honeycombed and very, very low. The inside of the part don't actually contribute much weight. The weight of these arms is mostly related to the surface area. And if you just increase the height of the arm, it's not going to increase the surface area too much. The weight of the arms don't go up that much, but the rigidity goes up a crap ton. So if you want to design strong 3D printed parts, more plastic. I'm in the Discord, and we have anytime we have a problem and something breaks, this is what we write now. More plastic. You just make it thicker. It's going to be good. So you might think that maybe you could do some cutouts in here to save material, yada, yada, yada. All of that adds weight to the part. So you want very simplistic parts and make them big. That's it. Okay. So let me actually just go show in Inventor. I actually did this. So here's the arms, and here is what they look like under displacement. I forget what the load is, but here I'm getting a displacement of 0.1 millimeters. Right now I think it's modeling with these being solid arms. Previously I had shelled them out. Inventor's not the best tool for simulating 3D printed parts. So what I do is I usually take the part and then shell it out so it has basically the thickness of the perimeters of the 3D printed parts and leave the inside hollow. So whatever result I'm going to get is going to be a conservative estimate for how good or bad this is going to deflect. So anyways, whenever I actually did the actual test, use your words, Nick. So whenever I did this with a shelled out part, I got about half to 1 millimeter, I forget, with the loads, with loads bigger than what I would expect. So I think with loads that I was expecting to have, like static loads, not dynamic loads, I would expect to get about 1/10 of a millimeter, which is pretty good. Maybe I'm missing something, very possible. But what I did do is I took this and I clamped one into the table, and then I set this on the other side, and I measured the deflection roughly, very, very roughly. And I got, with this arm has like 4 perimeters and 60% infill, so it's pretty Haas. I got about a little less, like probably half to 1 millimeter of deflection, and this is crap ton more weight than I'm going to actually put on the end. So I'm feeling pretty confident. And remember, whenever I have the arms together, the gravity is going to load things consistently. So if they're sag, they're sag. As long as I get consistent precision, I can use like mesh bed leveling and stuff like this to like hide some of my sins. So I'm not too worried here. All right, I'm getting close to the end of my questions, and then maybe I can go get your questions and then maybe show you some of my secret surprises. They're not secrets, but all right, friction torque on the rail. First off, again, the rails are over-engineered for this. They can handle it. They're rated for 50 foot-pounds. Not going to be a problem. I just showed you FEA on the arm. Can you print below the bed? Yes. In fact, maybe I need to change the tilt of the arm, and so I can get a better build volume. Like, it's an open question what angle I need, all of that good stuff. Yeah, what's the best design for a monorail? I can't stress, like, the idea that you can just have one rail and you can define all these different planes or multiple rails is not a new idea, but there's a whole class of possibilities that I've been exploring. And I think you'll guys agree after I show you some of the variants that, we have some crazy options in our future. I'm hoping to see lots. I'm hoping a lot of you guys go out and build some really crazy versions of it to solve your problems. Anyways, what software do I use? I use Autodesk Inventor. I get a lot of that question. Is Helios is that project still going on? I'm really passionate about Helios. I think Helios should be like the RepRap printer that everybody goes to if they're going to build one nowadays. RepRap's kind of going down, not downhill, but like it's not as active as it used to be because you can buy like $200 printers that are really good. But so I am working on a successor to Helios, and I call him. Where is he? I call him Homer. I don't have the arms on here, but this is the base and a pylon, and this center part can move up and down, and so the motors turn this, the hex shafts turn this gear, the gears turn the inside of an arm, and huzzah, you get a Helios. I'm calling it Homer because it can print the whole donut. That can print all around itself. And then you can see a carbon fiber tube here. I can run electronics up to the top. I can have a slip ring here to have electronics come out in a Bowden tube or whatever else I need to feed the filament in the electronics down to the end effector. I'm super stoked about this. Sorry I didn't get that mocked up a little bit more for you guys, but anyways, I think this one has a lot of promise. I hope to get to work on it soon. Getting a little lost. All right, so vertical rail. All right, so somebody in the comments had just like a day ago, 2 days ago, had a comment about could you have the one rail go in the Z, and like that's all it takes. One person mentioning something, asking that question, and then my brain was on fire, and we get this. I think this is like the cornerstone of this live stream right here. This, I don't even know what to call it. Maybe in the comments you guys can come up with some ideas. But oh man, how crazy is this? So one vertical rail. Well, I mean, I'm cheating. I have 2 rails, but don't tell anybody. So I have 1 rail. I don't have any arm collisions. I lose, based on how far that goes up, I lose about 300 millimeters of this rail, but everything else I get in Z height. So if that's a 1 meter rail, then I get 700 millimeters of height. And with the 200 millimeter arms, this is a 700 millimeter diameter semicircle you can print in. And you can pretty much get everywhere on it without any arm collisions. You can even get somewhat behind yourself. Anyways, it's pretty nuts, and it looks kind of friendly to me. Need to put some googly eyes on it or something like it. Oh no. Inventor just crashed. Is that what happened here? No? Okay. Woo. So, anyways, vertical rail, bam. It's a monorail. It uses the same basic concept, angles, different planes intersect, completely different form factors. So if you want it on a table on the edge, bam, you got that. You have a pylon, bam, stick it on that. I have this one, and I really like this one. I call this one the flying one. This is very crude, but I would actually do 2 rails so the middle carriage isn't stuck. But it can go down and left and right, and that one has a really nice build volume also. And so if you had a conveyor line, you want to stick it above it and like reach down and do stuff, that would be pretty good too. I see, I just happened to glance over at the live chat and see that somebody was asking, is Inventor free? And no, it's not free. So if you are in education, you can get all of the Autodesk products. So that, and if not, Fusion 360 does pretty much all that this does. I'm just not as comfortable with Fusion 360. And the animation suite on Fusion 360 is not quite as good, but as far as making the parts, it's really good. And I think it's free if you don't make too much money. Somebody in the chat can probably fill in like the actual details about Fusion 360, but anyways, if you start making a lot of money, they ask you to like pay a license fee or something like that. But anyways, there was some brouhaha lately about like Fusion changing something that made makers mad. I don't know. Anyways, somebody else can hopefully fill that in. All right, so that's my flying flying monorail. I don't know. All right, where am I at in my list? All right, wall mount. Did you mount it to the wall? That one that I just showed you? You could. You need to stand it off a little bit because the elbows sometimes get a little bit behind the rail, but not by much. And if you wanted to mount it all the way to the wall, then you could just deal with a little bit less build volume. Am I going to patent it? So it is open question whether this infringes on the Tripteron patent. We think it skirts the Tripteron patent, but I'm not a lawyer, and anyways, the reason we think it skirts the Tripteron patent is the Tripteron patent says that each of the axes are decoupled from each other and they're uniform in the way they enter. Anyways, in this case, I have asymmetric ways I tilt each of the carriages to accomplish what I want. So I don't get a nice decoupling, and I make my life a little harder. On the firmware side, just like slightly. So I think I don't infringe on the patent. Maybe I might try to file a provisional patent and just never follow it up. And what that would do if I did that is essentially like I'm putting a flag in the ground saying, hey, this needs to be an open source thing, and I don't want anybody else to patent it. That's what provisionally patenting something but not following up will do. So it's not like I'm trying to keep anybody else from using it. If I did happen to get a patent, then I would license this with a free and open source license. I don't even like doing the GNU license where you have to, attribute and all that stuff. I usually license everything under BSD or MIT. One of the license where you can just take it and do whatever you want with, and you don't have to like get back to me or tell anybody else that you got the idea from me. So I'll put that whenever I post this in GitHub. I'll make sure all that's super clear. A lot of people are mentioning that this could be used in space or like on Mars to print things. I would just like to point out, if you want to do something for space, long linear rails are hard. It's hard to get long straight things into space and onto Mars and in a space station and whatnot. What's not too hard is to get long things that aren't necessarily super straight and then have them pivot on each other. Which means I just need to do a plug for one of my past projects. So let me see. You need Simpsons. So if you want to go to another planet and you want to print, and you want just some arms you stick together and you can print something, you need something like a Simpson. So nothing but revolute joints, and voila, you can get a motion platform. So if you go to space, I suggest Simpson, Space Simpson. All right. Getting lost. Using two monitors, and I'm not handling this very well. Okay, so I'm working on one. Since you guys are here, might as well show you guys a little teaser about. I'm working on a little mini Tripteron, and let me see if I can. Oh, I think I forgot to open it up. Let's see if I can get this going. All right. You need to see my structure, my organization. Okay. All right. So this right here, I'm calling the mini trip, and so basically a board, steppers around the outside. These are linear steppers with screws, and I'm hoping that I can have the arms right on the screw and be held straight enough. I'm gonna go with small scale, so I have a hope that this might work, and I'm hoping to make a little tiny like 165 cube print areas with this, or maybe smaller. This might be a little bit too ambitious at that size. Maybe I have to shrink it down to like 120 millimeters, but I think it'll work, and it'll be adorable. And this is not a triptyron. I mean, I'm going to call it a triptyron, but it's not a triptyron because whenever one of the other axes move, it will actually change my position on the screw and mess my position up. And that makes the math oh so hard. So I actually need to have knowledge at all times about where my arms are in space so I can calculate the right things. So for the simplicity of just having everything just on a screw, I have to pay for that with some firmware, and I think I can pull it off. I think it'll be a super fun little project. Like who doesn't love a little cute printer? I'm sure somebody. All right. Okay, I'm getting close. Okay, accuracy, precision. I don't know. I mean, precision, I get a design, so I'm gonna have like the same precision that any other 3D printer has, positioning wise. Accuracy, I should have repeatability, and I should be able to calibrate everything. I should have as much accuracy and precision as I want. It shouldn't be a problem. I just have to go slow and calibrate. That's pretty much it. And screw that rail down to the table. A lot of people are just like, hey, it's going to twist. So anyways, there we go. Time to now go read the live chat. I think I reached the end of all of it. Is there anything I missed that I had that I wanted to show? Let me just go double check my inventor tabs. So mini trip, Homer, MonoRail, flying, Duo. So I was going to build this one, but I think I'm off of it. I am going to mock it up. I have all the parts that just got done printing, and I'm going to screw it together here in a second and just see how rigid it is. So I'll have a really good idea here in an hour if this is workable. Oh, since I have this up, a lot of people think that having the second rail over here is going to be a stability help, and it looks like it. It looks like, hey, I'm supporting from this side and that side, but if you pay attention to these, the top arms, they support the effector none at all. They have no help against gravity. The only thing that's working against gravity is this arm, and the math doesn't matter. It doesn't care whether it's on this side or that side. So the MonoRail or the DuoRail, both of them have the exact same support for the end effector. So you don't have to worry about. Yeah. Anyways, the reason I went to the DuoRail is just so so this carriage here is not trapped between those two. That's the only reason that the DuoRail exists. And it's just kind of a neater form factor for like, hey, this is where I'm printing, and I can put steppers around the outside. So you know, it's kind of a cleaner layout than the MonoRail. I'm sure I could do a MonoRail justice, but I couldn't just have one rail. I'd have to have feet and all that stuff, and so I would already have to have some other extra junk, and I think it'd kind of mess up the lines of the MonoRail. So I kind of thought this might do it, but now that I have this one, I can make that so clean, as clean as I want. And anyways, I think a few people have said like, hey, art installation / 3D printer. Yeah, I think this will get the looks for sure. All right, so I'm going to, this might be, I don't know how the best way to go do the live chat. I'm going to maybe scroll all the way back to the very beginning and try to just go super speed through them. So here goes. All right. Okay. Alexandros asks, have you considered using a linear motor on the rail? I'm not sure what you mean by a linear motor. Maybe I answered that already a different way. Let me know down below, and I'll maybe do a follow-up. All right. Tommy Thorne asked, would there be a significant twisting force on the monorail? And yeah, I mean, not significant, not more than a rail could handle for sure with what I'm going to build it for. But you know, you should bolt it down. Anything that long on the order of meters, even if it's made out of metal, is pretty twisty. If you do the calculations, it doesn't take much to get a little bit of a deflection. They can handle the forces, but would it actually bend down and cause some problems in positioning? I don't think so. Not a whole lot, but I mean, it would be a factor. So might as well bolt it down and not make it a problem. All right, we got Sakatlinga. We just need somebody to write the firmware, and I talked about that. We're done. Tommy's talking about how good trinamic steppers are. I agree. Let's see, Waffle Beaumont. Instead of using a linear rail, which might bend down a little, as some people have mentioned, I think that maybe two smooth rods separated by some distance might give more rigidity. And so this might be a counterintuitive thing, but long round rods are very very bendy. Pretty much any robotic machine designed over a certain size, you'll transition away from smooth rods to rails that mount to some rigid frame. It's very easy, like that BH to the third formula I'm talking about. It's easy to add the mass, and so like you don't want your precision component to have to be that big just to get the rigidity that you want. And so you have a smaller precision component and you mount it to a large massive thing. So anyways, hopefully that answers that. Let's see. 2 linear rails either side of an extrusion, perhaps. Yeah, 2 rails would be better than 1 as far as like if you straddle with carriages on each. But I think this, I'm going to use an MGN 15 rail, and those are rated for like 10 times more torque than I need. All right, are there plans for the machine? Let's see, Radish Dalek. Are there plans for the machine to have positional feedback? I imagine a single magnetic strip shared by each sensor, 1 sensor per carriage. And so, yeah, feedback would be great. So if you miss steps or something like this, I'm going to use this controller here, and it will actually know if it misses steps. And so I can actually know if I ever lose position. So I'll just tell it where to go, and the steppers will go there. And if it ever can't handle it, it'll miss, and then I can take action then. So any kind of feedback on the carriages won't really give me any more than what I already have. If you had like a servo drive and you could make a cobot where you could interact with it and push on it, and it could move out of the way and then move back. And I don't know, there's some really cool things you could do if you had feedback. But what would be the most useful feedback is actually on the effector, to actually know where the effector is. And as far as I know, there's not really good solutions for finding that out cheaply to the precision that we need. So basically what we all do whenever we build 3D printers is we build it rigid, and we tell the steppers where to go, and we hope for the best. So all right, let's see. Tommy Thorne asks, so the benefit of the monorail over dual is save space in one end and one fewer rail, whereas DuoRail is a lot more stable. So the DuoRail is not for stability. It's only for more print volume. That's it. And I just thought it looked cool. All right. DJ, hi. Not sure if it's been asked before, but do you think the monorail might be suitable for a cheap, large-scale CNC for cutting 4x8 plywood? Yeah, that's tricky. Can you do it? Yes. Do I think it's the appropriate solution? No. You should. I think it's called the Maslow. Anyways, there's this. You can basically get a wall mount thing, and it has you get some strings, I think, or a chain, and then you have your router suspended between these chains with a brick or something. Anyway, so you just pull on these chains, and it moves the thing around, and it machines right on the wall. It's a fantastic way to machine things. So if you want a 4x8 plywood miller, I would suggest something like that. I think this one the engineering that would have to go into something on that size would be cost prohibitive and space prohibitive. All right, everything working. Sounds good. Okay, it seems like TMC enables you to drop the in stops. They fill the stepper stall. Not sure if they're accurate enough for bed probing too. Okay, so yeah, TMC drivers or Trinamic drivers can tell me if I stall. So I will not have any in stops. I'm anti in stops. If you can get rid of a part, no part's the best part. And so, in fact, since the resolution's the same everywhere, I will start early on by just putting the effector on the bed and say go. It doesn't actually need to know where it is. It just needs to know how to move from there, and everything's consistent wherever throughout. So that's really cool. But yeah, eventually, whenever I get homing routines, I will use that in stop detection, or I will use the stall detection. The stall guard is what it's called in the TMC driver stepper drivers. Is it good enough for bed probing? I think the consensus is no, it's not good enough for bed probing. For two reasons. One, it's only like down to like 1 or 2 steps, and I think you lose your position after you do it. So you would have to home, which using stall guard to home is not as precise as using in stops, and then you would have to then go back and probe again. So it would be, I think, maybe I'm wrong, but I think it would be a very long process. I'm going to use a DC for. I'm going to use an IR sensor. Yeah, so it'll shoot a modulated IR beam down at the bed and then pick it up at a different angle, and it'll move down until it finds the strongest signal. Anyways, as long as you don't have a glass bed, it'll work great. You do not want to use stall guard with a lead screw. You could if it was a high enough lead screw and you turn the current down. So yeah, that's another thing is whenever I go to like try to stall it and like run it into an edge somewhere, you just got to turn the current down enough so you could skip steps and actually get it to stall. All right. How long a monorail would I need for like a 30 millimeter build volume? Okay, so the monorail as drawn, you need about 500 millimeters on top of whatever width you want. So if you want to build something 300 millimeters tall, you need a 800 millimeter rail. Depends on that's just a rough rule of thumb. It depends on how big you want your Y and all that good stuff. But you know that for the way I have it drawn, I need 500 extra millimeters for however wide I want. Could the angles be optimized for a CNC router to be more rigid in X and Y? Yeah, I think in general, Triptyrons are just not going to be the CNC router platform, unfortunately. I wish they were. All right, I had based on your. Okay, so J.K. Lee, I had built a quick draft based on your idea. The Z position quite hard to define with 15-degree tilt angle. Yeah, so I think 30 would be the smallest I would try. I think if 30 doesn't work, I might have to go to 45. And as the angle gets bigger, then I lose more capabilities and like where I can reach, and like I have to use more longer rails and that kind of stuff like that. So I'd be curious. Maybe you guys, maybe you can message me with your test or a video of it. I'd like to see how good it is and what it looks like. I'd love to see that. Let's see, waffle. No, okay. It seems like the volume would be a funny shape. Do slicers have support for that? Okay, good question. Slicer support for the build volume. So if I'm talking about the space elevator one, I don't know what we're calling it. I'm calling it vert in my head right now. The one rail that goes up and down, that has a very basic semi-circle build volume. What I do in Cura is here. Let me just a second. Let me switch it where I'm just talking. Okay. Okay, so what was I talking about? Oh, Cura or slicers. So different slicers have different ways you can do it. So normally you can do circles, you can do squares, rectangles, you can have restricted zones, and so I know Cura you can like bring in as many restricted zones as you want, and you can like essentially like restrict to whatever area you want if you're willing to like build your own. And you could also bring an STL in to like represent your build platform, so you can just visibly see where you need to place something. Now, as far as weird upper volume stuff, there's not much support, so you kind of just need to know what's there and then place things accordingly. I need to maybe experiment in Cura. Maybe I can have an STL like actually come up and like kind of show me where it is. Just kind of give me a ghost feel for where it is so I can move things around. Slicer has a way you can bring in an STL and it'll slice the first layer and use that for the build platform. But it still will assume that you have consistent, you have access to all of that for the full Z. So, anyways, it gets tricky whenever you don't have a consistent Z. Okay. Let's see. All right, PRXRB. Any issues with singularities, arm stiffness, and backlash? So singularities, unless I let the joints, as long as I don't let the joints like come together, as long as I keep them separated a little bit, no singularity issues. Backlash, not going to be backlash shouldn't be an issue as far as I know. Everything's very springy, there's like backlash where you move from one direction or the other direction, it's going to have a different position. I don't think it'll like stay offset. It'll spring back to a normal position. But the stiffness will be a problem. And so as you know, as I load this up, the arms are going to torque a little or twist a little bit. So yeah, stiffness will be a problem. I'm going to keep an eye on that. Any ideas for varying arm lengths in the same machine? Yeah, in the MonoRail video, I actually had 2 different arm lengths to kind of keep the elbows from knocking. And so yeah, you could do that. The problem with that is if you have different arm lengths, you can't get close. You exclude a region around the pivot that you can't get to if the arm lengths are different. So if the arm lengths are the same, you can get as close as you want. So basic idea is to have the same arm lengths. But from one set of arms to the other set of arms, you can have different lengths. So in my in this space elevator one. You guys can come up with a name. Right now, I call these the Z arms. The ones on the bottom are that control the Z height. Those are too long. I can make them shorter. So I would make them as short as possible to keep the flexing to the minimum. So any length I can get rid of, I get more rigidity. So since these top ones are angled down, they have to be a little longer to match what this shorter bottom one would be. But just for the mock-up, I used all the same arms, so I don't have to think too hard. All right. Okay. So if you have a, let's see, M14SRV. If you have a circular rail, you could print using radius, angle, and Z. Yeah. Let's see. Okay, Catlinga, circular rails exist? Question mark. Do they? Yeah, I don't know. I feel like you'd have. I don't feel like they make too many. I'm sure they could construct them, but I assume they make them straight most of the time. So, does RepRap support 5 to 6 axis printing? Yes, sort of. So this board that I have here, it can support the firmware for that, and I can send G code for that. The problem is the slicer. So how do you take apart, figure out how to decompose it? That's something I'm working on But yeah, there's a few 5-axis slicers out there. None of them do it the way I would want it to do it, but you know, they're getting out there, they're doing something, and they're moving the ball down the court. So yeah, super awesome. I'm hoping that's going to mature. I'll see what little I can do in that front. Would it be possible to have a vertical rail with a single arm instead of horizontal with 3? So, Davey, I hope I answered your question with a space elevator. Single arm, yeah, you could have a single arm. You know, like that would be like a Helios kind of bot. But using this concept of having each arm define a plane, then you really need 3 arms. All right, let me zoom down a little bit. Carbon fiber filled PLA, actually making a carbon fiber mold. Make it carbon fiber, nanotubes, titanium, unetadium, YouTube comments, engineering. Yeah. Why would you make a very expensive proof of concept? I guess that's like, I'm trying not to. I'm guessing you're agreeing with me. So, yeah, I'm not trying to make a, I'm trying to make it pretty cheap. Just PLA, the cheapest rails I can get, some belts, blah, blah, blah. If you really need to, you could wrap carven roving along the outside of the 3D printed arms. Yeah, DJ, I really like that concept of where you print the part and then you can reinforce the outside. If you're going to do carbon fiber, you know, I would say that would be a good way to do it. But again, if I can, you know, I want to make it where somebody can just take a part, print it, go use it, and you don't have to do anything fancy. All right. All right, non-planar printing. Yeah, I want to get into that. Great project, short. Okay. Okay, any news on the Wheelios? I don't really have any plans on it. There's so many belt printers now. There's not really a need for Wheelios. It's more of a student project. Yeah, maybe he'll come back in the future, but yeah. Yeah, I don't have any plans. As you see, I have a lot of concurrent projects going on. Okay. Sorry, scrolling for a question. What accuracy could we expect for the monorail? Decent. I think it'll be good. I'll put it together here in an hour or so. We'll see. I'll do the squish test with my finger. I think it'll be good. I hadn't heard about the Tripteron until I saw your video. It's very cool, especially on a single rail. Imagine if it was really big to deliver stuff throughout the city. Yeah. Again, I think scaling's not as good as a lot of people would hope for. So yeah, we have 2 camps of people that watch my videos and comment, like the ones that want to like take it and like make it super huge, and then ones that are like, that will never work. The torque and the friction will be way too much. So I think the reality is somewhere in the middle. So I think this is going to be kind of a good medium-sized printer. I don't think you want to go too big. Vertical printer could be interesting for 3D house printing. A single column, the arm could rotate around. Yeah. I mean, here I'm going to plug Simpson again. If you want to print a house, I say get 3 semis with Simpson arms on them. They come together, connect, and print the sucker. Nothing but revolute joints, no fancy linear action whatsoever. Long, like linear motion at scale is super expensive. Can't stress that enough. And so if you go big, you got to go revolute. You can't have sliding action. I mean, I guess you could have like train tracks or something like this, but then you have infrastructure problems. Again, cost issues. Semis, Simpson arms, go. Okay, let's see. All of these systems are linear, which means that the resolution is constant over their work volume. Yeah, Apsu, that is right. I'm guessing you're answering to other people. Okay, Apsu. The original orthogonal 3-arm Tripteron is also Cartesian, but all of them are linear. Yeah, so yeah, this is linear. It's very close to how a Core XY works as far as the firmware. But yeah, the original 3-arm Tripteron, you guys should go Google it. And man, one arm moves. It moves in one dimension, X, Y, or Z. It's all decoupled. It's amazing. Like it's like they deserve the patent. I wish they wouldn't. They would let us license it, but they definitely deserve the patent. All right, let's see. 10 saved models limit in Fusion 360 now. So that's quite a restriction for at least me. I would have trouble with that. But, you know, the great thing about Fusion 360 is that when you have a project, all of your models sit within that file. So you model multiple parts in one file. So the inventor model is every single part gets a different file, and so you would. I mean, I could not do a project with 10 saved parts. Anyways, you could, in theory, like have one file that has multiple models in it if you were running out of space with the 10 limit. Okay, actually it's 0.31 midnight right now. I won't sleep definitely. Okay, sorry, I'm keeping people up. Okay, the Flying Monkey, that's a good name, David. Constant resolution along the rail, but how about as you move away from the rail? Yeah, constant resolution everywhere. All of my designs I showed you tonight, all the MonoRail derivative ones have constant resolution. It's very counterintuitive. But yeah, just think about it. I have each of the arms define a plane, and whenever I move them, it moves them a linear amount. And so that would move the position of the effector a linear amount. All right. Someone asked Legal Eagle. LOL. Yeah, please do. Can you please post the live stream to YouTube after this is done? I can watch the stuff I missed. Absolutely. Did you look at the patent? I thought a patent has to be very particular in what it covers. It is, and I think we don't infringe upon it. Apsu in the comments, she looked at it, I looked at it, a few other people on the Discord looked at it, and we don't think we infringe on it, but I'm not a lawyer. Okay, you could probably put the one with the downward R's over a belt and print infinite Z and dodge a patent. Yeah, if I wanted to dodge a patent, I could. The point is the Tripteron patent expires September 2022, which is not very long. I mean, if I wanted to make a product and sell it, which I don't, I'm not a very good business person. But if somebody else did, it would be before then, before you get it out, anyways. Now, the open question is a coupled Tripteron, like the original Tripteron patent is for the decoupled motion. There could be another patent sitting out there that covers coupled motion, where each of the axes mess with each other, like mine. So I don't know. I'm kind of leery to do a search and like try to find that out. So don't like patents. Okay, be sure to hit the like button if you enjoy the stream, folks. Thanks for that public service announcement, Apsu. If yours uses OneRail, that's a different process. Yeah, the patent doesn't dictate the number of rails. It only dictates the way each of the axes are decoupled and whatnot. I think we skirt that. All right, is the fourth stepper spot for the extruder? I'm not sure what you're referring to, M14 SRV, but yeah, I'm not sure what you're talking about, but yeah, usually the fourth stepper spot is for the extruder for me, the way I design stuff. This is a core of an old Helios, and so all those three steppers do X, Y, and Z, and then the last one is facing up, is doing the extruder. So this is about the tightest arrangement you can have for steppers. And anyways, let's see. I'm in love with this. Thanks. Oh, I lost my spot. Oh my gosh, some of these are hilarious. Oh, I'm so far behind. Okay. Um, oh, I can't answer all these. I'm gonna skip to the end, and I'm gonna get the stream of consciousness ones. And if you want to like ask me another question, just throw it at the end, and I'll try to do my best. I'm just gonna do stream of consciousness at the end, and we'll go until you guys get tired or lose all my viewers. I don't know, or I have to go pick up my daughter. So could the arms be made without the circular bearings, just 3D printed compliant joints? Yeah, that's an exciting possibility. The problem with compliant joints is they are compliant. And they are usually compliant you design them to be compliant mostly in one way, but there's usually a little crossover where they're slightly compliant in other directions. And the beauty of just cheap old bearings is, they're only compliant in the 1 degree that I allow. So compliant joints are going to be a trick. Not saying they can't work. I definitely would. I'm gonna probably explore compliant joints on maybe a Simpson build in the future. I think that might be a better fill. This requires that the arms define a plane very well. But I have other builds where it doesn't really matter like how the knuckle, whether it twists or whatnot, as long as I drive the distance between the two ends. And that one is way more useful for compliant mechanisms. Okay, is the factor for the MonoRail build volume versus... Okay, there's not a factor. It's just that whatever sorry, I didn't read the question. Is there a factor for the build volume to the rail length? It can be whatever you want. Basically, whatever X range I want, I have to add 500 millimeters for the original MonoRail. And for this space elevator one, I have to add 300 millimeters to the rail on top of whatever Z I want. So anyways, you can pick whatever factor you want just by making it extra long. Check linear motor video. Yeah, that's cool. Why do you build so many printers? I have a disease. So whenever I first got into 3D printing, I felt guilty printing tchotchkes with like this amazing piece of technology. I got one of the original wood printer bots from the Kickstarter. And so I was like, hey, I want to build a 3D printer, but I don't want to just build any 3D printer. I want to build a 3D printer that doesn't use any linear rails. And so it's more RepRapable. I'm still a big fan of the RepRap project. If you don't know what that is, hey, can you make a 3D printer that can build another 3D printer? And you can take that to whatever extreme you want. But mostly it just means like make all the plastic parts. But if I can make a printer that's mostly plastic parts, then with no linear rails, that's better. Do you show how to get the inverse QMNX for any of this machine? So that's a good question. I mean, I'd have to do a little bit of math for the angle, but mostly I just look at it and it's like, hey, to move in the X, they all move together. To move in the Y, they move together. So building that matrix was pretty much just reading it straight off of looking at the motion. So so sorry I don't have any like deep math for you there. Let's see. Repost question from above. See there are 2 rails on 2 connecting sides. Could you have 2 rails on the opposite side so you could use rollers like some of the cheaper printers? Yeah, you can use V-rails with the wheels. I'm tempted to use those, but I kind of want to. I haven't used professional linear rails yet, so I think this might be the project that I get some and just see how good they are and benchmark them, just so I know for future builds. Okay, so also I vote to call the vertical printer a monopole. Oh, that is the best name. All right, Waffle, that's winning it for now. Okay, let's see. Check linear motion video. You can put 3 carriages on 1 magnetic rail. No need stepper motors. Yeah, that if you have a link to cost-effective linear motors where I can do that, I want to do that. I just don't think we can compete with the steppers at this point. But yeah, maybe down the road or for like some high-speed version of this. I don't know. It'd be super sweet. Okay, the mini Tripteron could use a horizontal 1 3 sides of the bed. I don't know what that means, David. Yeah, yeah. Can you clarify on this mini Tripteron question? All right, which Duo model are you using? And I think that's been answered, but it is the Duet 3 Mini 5 Plus with Wi-Fi. Wi-Fi. 3D printer compliant joints isn't going to last. You can 3D print bearings instead. I would beg to differ that compliant joints can last a long time, especially if you make them out of nylon or some other material. There's a different, I can't remember what the material is, but there's a material that's better than nylon for living hinges and whatnot. In fact, that would be my first go-to. Is I wouldn't make like I would just go with living hinges to replace bearings, and I would probably get purpose built. I would probably get off the shelf material for that, and not 3D print it if I was to go with living hinge. So how expensive are those linear motors? I do want to know. Okay, I got lost. Okay, just asked an engineer. He says 2 linear rails in a train line type arrangement. I don't know what that means. Okay. What angles did you use for the linkage arms mounting points on the linear rail? So on the outside ones I had 45 degrees, and on the one that's tilted a little bit in the middle I used 30. Those were just picked with what I thought looked good. I haven't done any science on it to see what's the best option. So that's an open question. And again, I'm not going to build the MonoRail. I'm going to build the monopole, and it's still an open question what the best angles for that one are. Right now I'm doing a tilt down 30 degrees for the top ones, and then obviously the Z's flat. I like 30 because it has nice math trig, like the components of it are either a half or square root of 3/2 if you're into trig. So that will make all the math on the firmware side pretty easy. It's not as complex as it looks. Yeah, it's not too bad. Okay, why not use belts instead of rails to be more 3D printable? I'm not sure what you mean by using belts instead of rails. The rails are used to guide the motion, and the belts are used to drive the motion. So we could probably 3D print something like rails, but I don't know. All right, let's see. I'm getting lost again. The belts can't carry the whole assembly. Yeah. You can't 3D print belts. That's not true, but you can't. I mean, belts are cheap, so buy them. So could the vertical printer even have 360-degree motion if the motors could rotate around the pole? The way the angles are, I think the answer is pretty much no. You could reach around to the back a little bit, and you could get big enough bearings and like put them around the pole, and you might have, it might be a little bit, I don't know. Basically, I think the semicircle's kind of a good restriction on the vertical printer, but I'm keeping an eye on it. Maybe I'm missing something. Reposted question: have you already considered dynamically balancing? Yeah, you could totally have other arms that are off the back that are doing opposite motions, and so everything stays balanced, and you don't actually need to have the motors work too hard. I don't think it's needed. These are all light, but I'm definitely thinking about it. So I might counterbalance if I need to. If you gear the middle motor down in double arm length, you could probably keep the movement by moving the arm half the distance. So for the original MonoRail is that right now I have a 30-degree angle, but if you reduce the angle to like 15 or 10 or 5 or degrees or whatever, you could move it less to change Z more, and you could gear it down and you could get more Z. But the more you do that, the more you lose Z resolution. And you don't want that. So I think 30 is kind of a happy, you get about half the resolution as if you were actually driving Z directly. So half is pretty good. My mind keeps racing towards seeing the MonoRail printing in 0G, multiple monorails per object. Oh yeah, that would be cool. Polypropylene. I got lost again. Okay, Duet boards are great. Such printers could be used to print wings for airplanes. Sure. Open and closed loop feedback system. I'm going to go with the one where I don't get the feedback. I always forget open or closed. I don't know why that's so hard for me to remember. So for something like a 150 cube monorail, I would need a 650 millimeter rail. Well, if you're only going to reach out 150, you could probably get by with a little shorter rail. But yeah, it would be a ridiculously long rail for that. Basically, you don't want to build a 150 millimeter cube monorail print volume because, like, once you have a rail that's that long, you can just add a little bit, and it makes it a little bit a better match to the print area. I would say use the monopole if you want to print a 150 by 150 by 150. You could have little baby arms and make that one work. This guy is talented. Thank you so much, Fantasy Engineered. Oh, hey, Bill. Still, the cool thing about MonoRail printer is that you could have a single printer, for example, on the space station that can print locally, but be available for the whole station. Yeah, the idea of like you could like run a rail down like a conveyor belt or a wall of a warehouse or something like this, and it could go and go visit things. It kind of reminds me of a movie. I want to say Moon. Sam Rockwell's on the moon, and there's this robot that goes around on a rail, and it can go visit from room to room and do things. So it's pretty cool. Are you going to build this monorail live? I think I'm gonna sign off here. I might go pull the computer and go show you the parts at the end here. But I think I think I'll sign off tonight. But I will film it and make videos about this. I'm the 69th person here. Nice. Okay. So it sounds like the DuoRail is the priority. No, the Duo isn't. I'm going to do the monopole one probably. That's what I'm leaning towards. Of course, it changes by day. I always like somebody will make a comment and make me think about something new, and I'll go in a completely different direction. But that's an awesome problem to have. Okay, so saw a Disney research video where they were mapping animations onto robot skeletons. They modulated the motor profiles by optimization to prevent oscillations during motion. Thought of MonoRail. Yeah. So I guess the new hotness is Clipper for firmware, and you can like put an accelerometer on the head, and you can do input shaping. And so I could tune this thing to perform very well with firmware that we already have, with actual feedback from the effector, which is just amazing that this is all together. I mean, I don't know. It's cool what people are doing. The cool thing about the monorail is you can unbolt the rail and fold it up and put it in the corner of a closet. Yeah. Are you aware of the Gerbil ESP32 project board? I'm not sure what that is or what that project is. All right. Have you ever thought about building an origami printer? Oh man, that would be cool. I have. I don't know how I would do it, but I want to. I'm thinking, something that, would be on a Walmart shelf. Maybe this would be horrible, but a disposable 3D printer that you build, and it's made out of all of living hinges. It can print a few things, and then it has end of life cycle really soon. Like those things are coming, unfortunately. I don't want to be so wasteful, but they are coming. Like whenever we have $160, $100 printers, it's only a matter of time before it's under $100 and on the Walmart shelf, and a consumable. All right. You can design with arms with counterweights. Yep. Good luck to builders. Yep. For reference, okay. The movie with all the clones. Yeah, that's the movie I'm talking about. Feedback does not change the result. Yeah, feedback's not going to help me here. So I want feedback on the effector, but I guess the best I can hope for is put an accelerometer on there and get some input shaping with Clipper. I wanted to build a monorail as soon as I saw your video, but worried about the forces on the joints, not along the rotation plate. Sorry if answered, just Yeah, so it's all arm rigidity. It's not really like like torque resistant or anything like this. Best living hinge material is polypropylene. Oh, nice. That's what polypropylene was about, or polyethylene. Okay. We can make the monopole rotate. We could. I don't think it's needed. I mean, just put another one on the back, and then they could work together. Wally. Wally is one of my past printers. There's a printer that just kickstarted that Burke Drum was working on. That's a five bar. It has two arms with the elbows kicked out, and it can print out. It can print like this, and then the bed goes up and down, or the arms go up and down. And it's kind of like the Wally, and it's made me want to do the Wally again. But I actually sat down and modeled a new 5-bar like my Wally to kind of resurrect him. But I kept on going back to a one-arm Scara, so I think I'm done with 5 bars. I can't. I'm pretty good at building one-arm Scaras, and if I can print the whole donut, you know, that has better capabilities in my book. So anyways, I keep on simplifying 5 bars down to one-arm Scaras. So yeah, a rotating monopole would be awesome. It would be, but I think it would be. Yeah, I don't think it's necessary. But if you did have it rotate, you could only have 2 carriages, one for the top arms and one for the bottom. And so yeah, basically, if you're going to rotate, that gives you a degree of freedom. So I can steal one away from somewhere else. So get rid of a top carriage and just have, anyways. So the top one will determine how far out the arm goes, and the bottom carriage will determine the Z, and then the rotation. So basically, you'd have a polar printer. Please start a Patreon or Super Chats. I'm working on it. I just recently got to the point where I could monetize, and so Google's mailing me something where they're going to give me a number in the mail, and I had to type it in, whatever. Surface area of the bearings and sufficient cross section of arms is all that matters. Deflection can be well controlled. Yep. Oh man, I got lost again. Input shaping is currently under development for RepRap firmware. That's amazing. Yeah, I can't wait. Regular deep groove ball bearings should be able to cope with these forces. Yeah, I'm using 6806 bearings, which are like way above and beyond anything I would ever need. The basic thing I'm needing is just big surface area, and so I can really define the plane, and so that's why I'm going so big. But they're cheap. Bearings are cheap nowadays. Just wait till 2022 AI arrives. Good luck all. If you check my channel, my original Tripteron build shows sufficiently rigidity to counter deflection concerns. I have a video. Yeah. So yeah, Tripterons exist. These are Tripterons. This is going to work. I don't know. Put that in a logical argument. Let's see. Apsu, she built the Tripteron with 608 bearings, and it worked good. And these are way over engineered past that. Yeah, it's gonna work. Check out the Zatsit printer. Yeah, the living hinge printer. That Origami Delta is amazing. Yeah, everybody should go check that out. iRobot or Star Wars. Oh man, I'm an Isaac. So it was just my birthday on Pi Day, March 14th, and Isaac Asimov was born on my birthday, and he wrote iRobot, so I have to go iRobot. Did you experiment with OBC filament? You'd have to fill me on what OBC filament is. MonoRail with living hinges seems like it would be super neat. Yeah, and I think that would be very doable, but yeah, it's not something I'm going to jump to right away. Important question, best sandwich. Oh, man. I mean, if I was at home and I want a sandwich, I would make like a grilled cheese sandwich with also a fried egg and turkey inside with some pepperoncini peppers and maybe a little bit of mayo or Miracle Whip on the inside. Pontusborg is working on the Plybot. Oh yeah. Yeah, Plybot's amazing. You guys rock. Pontus, if you're in here, awesome work. You and Brooke, Whole team, great. One extra stepper motor versus two more rails. I'm not sure what that means. When I first saw the MonoRail, my immediate thought was, wow, that's the most bare bones you can make a printer. Was that the intention, or do you think there could be a printer with less parts? Okay, so when you see the video, you might get a false impression that it's super simple because I stripped away, there's no belts, there's no control box. So there's still going to be a lot of stuff that has to come back that's not shown. So yeah. There, anyways, it is pretty simple. I'm hoping it works well. I mean, it will. Just, is it good enough to be competitive with current 3D printers? Will people want to build it? Yada, yada, yada. Okay, since each part, each arm is a constant length, you could run a pulley system along an arm to make a direct drive printer with remote extruder motors. Oh yeah, somebody made a Prusa that had arms essentially like this with belts that go along it that ran over and then drove the extruder. So you could just use the arms that are already going there to do a direct drive. I'm not going to do that. The orbiter is so light that yeah, there's no need. And then yeah, I think all the weight to do that might be close to the weight of the orbiter. They're amazing. At least I haven't got one. Everybody that has one says they're amazing, so I'm going to go with that. OBC stands for olefin block copolymer. The question was more for... Okay, got it. So when do you think you will have one of these built? I want to try when you release the files, if you decide to. I will I will build it as fast as I can, but I have a day job, so this is just extra side thing. I do have spring break next week, but I am remodeling a house, so so anybody's guess for whenever this will progress. Hopefully it's so simple that maybe some other people will give it a stab. I'm not going to be offended if somebody beats me to the punch. If somebody needs me to help them with firmware to get off the ground and they got the mechanics built, then great. There's not much, the files, I can share them, but there's not really that much to some of these files. Yeah, I don't really want to share it until I have something that kind of works, because I've found out in the past that putting files out that that don't necessarily work will turn into a support nightmare. So even if I put like a little banner across the files that say, hey, these are experimental, yada yada, build at your own risk, like people will email me and they're building something and I will want to help and I'll be jazzed about it, but then that'll really whittle away on my time. So anyways, I want to use my time and be jazzed with other people talking about like crazy new ideas instead of supporting my printer. So anyways, that means I need to get things in order, which also means I need to probably get somebody else on board or a couple other people on board to help me document as I go, because I'm very bad at that. So there might be calls in the future for people to possibly help out, do what I'm very bad at. Okay, you said mount another arm on the other end of the monopole. It's cost prohibitive. I was thinking if you can make it rotate around, would be much easier on the wallet. Well, not hard, but to get the bearings in the base to rotate would be probably about the same cost as a whole nother set of arms on the top. So you could have two sets of arms printing twice as fast, or you could have it rotate and print the whole donut. Anyways, if you're talking just cost, it'd be about the same. But I could see why you'd want to rotate and just have one arm that can print everywhere. So I can see the appeal. Yeah, and it wouldn't be super expensive. They sell really big bearings for like $25 for the size that you would need for that, and you need two of them. Yeah, you could do it pretty cheap. In your opinion, what's the engineering plausibility of an almost all compliant mech FDM as much as possible except for the steppers? Yeah, done. Like we got all the tech. Everything exists. We have to have the will and sit down and look at all the possibilities. And there's a lot of different formats that it could. We could go Delta, Simpson, regular like there's a million different ways we could build it, and we just have to go through them and compare and contrast them and figure out which one's going to be best for a compliant mech FDM. Yeah, we can do it. We just have to have the will and the desire and work on it. Apsu, I think it's fair to say Tripterons are one of the simplest 3-axis parallel machines you can build. The only other one is a linear delta. And I would say the linear delta is more complicated to at least to think about the firmware and all that good stuff. What was I going to say about the Tripteron? Oh, parallel machines. So if people that don't know the lingo, parallel means that you have arms coming in. Well, there's multiple paths from the ground plane to the effector. So in this case, we have multiple arms coming into the effector. That's a parallel mechanism. And there's kind of a divide between serial robots and parallel robots. You know, if you have a robot arm, a 6 degree of freedom robot arm, you know, you have all the axes stacked on top of each other. Each air will multiply as you go down the arm. But a parallel robot, if I have a problem with one axis, like it's not going to multiply the air across all the other axes. They're all coming together. So you have that advantage. I will build a monopole as soon as it's ready. Awesome. Zatsit disappeared, unfortunately. Yep, those things happen. But the idea lives on. Can we see the parts you just printed? Yeah, once I get done with the questions, I'll go pull the, I will try to pull I have everything plugged into this computer, but I'll try to pull it so I can move it. I'm going off the webcam on the laptop. And maybe I'll give you a little tour of my school lab. Wait until someone asks you to do a multi-head system. Yeah, you could do that. It shouldn't be a problem. Just throw in multiple effectors or a tool changer. The beauty of this is it's kind of like a polar one, but the orientation of the effector stays in the same spot. So you could have a tool changing station. Let's see. I have an 800 millimeter MGN 12 rail collecting dust. So it sounds like you know what to do with it. For compliant-based printers, look up Zatsit. Yeah. Is Concepts Forge still a thing? Do you people hang out on RepRap Discord or something? So yeah, I hang out on Discord. Maybe if Apsu's still around, she could drop a link for the Discord that I hang out on. There's a little channel on there for custom built in RepRap printers. I don't do the RepRap forum anymore. It's a fine place, but I felt like it wasn't feeding my creativity and it was sucking my time. The Discord might do that in the future. So, but anyways, is Console Forge still a thing? No, I poured a lot of money in some stuff that nobody even knew about. I was developing a board, and also I was doing all sorts of things for a 3D printer startup. And I just lost steam, and that's kind of why I went dark for a little while. I was mostly kind of embarrassed to not complete my designs, but then I was also like going to do a startup with Simpson, and it's like family members loaned me money, and anyways. I'm in debt still to this day because of Concept Forge. So sore subject. But yeah, it's all good now. I'm working my way through it, getting all square, and I'm finding a way to be happy in this space, creating. So one thing I know is I'm not a CEO type. I'm not gonna be good at a startup. I might be able to be a good tech lead. But I'm definitely not the money person, not the one that's going to drive everything. Okay, let's see. I should talk about joint design. Someone asked a lot earlier about it. So let's just go open up a joint and we can go look at it. It's going to take me a second to reorient here. Okay, I think I'm here. Get to an arm, and let's go and I think I can go to view and get a half section view, and then I can go find a plane. This is get out of the okay, half section view. All right, here we go. It might be kind of hard to show here, but there is the solid top piece, and then there's a separate plug that comes in that screws into the other piece, and then there are these two captive bearings here, and that's all there is to it. I designed it this way mostly to be cool. The bearings are cheap, and the arms look cool, but it also gives me a wire way if I ever want to route wires or a Bowden tube, a reverse Bowden tube. I'm not going to like actually have I'm going to have a direct drive extruder, but I do need a way to lead my filament to the effector, so I can put it through an elbow if I want. But I don't need to do that everywhere. I could get rid of one of these 6806 bearings and replace it with a 608 bearing and just have a bolt through there. And it'd be just as effective. But I think these look cool, so I'm gonna go with it. They seem rigid enough. I like them. All right. From what I gleaned from Kickstarter updates, Zatsit creator had cancer relapse. Maybe the disease caught up with him. Oh man, that's sad. I'm off to go obtain calories. I am very excited about the monopole. Looking forward to any updates in the future. Let us know if you'd like assistance. Nice, thank you. Nice username, by the way, Waffle. Yeah, I missed the old Concept 4 Forge. Yeah, I'm really sorry that I didn't like support that. I should have left it up, and but Discord is kind of a better like all-included solution. So maybe I'll start up a Discord for crazy idea people. That kind of exists on the Discord I'm on right now. Bring back Concept Forge. Sorry to hear that. Let's see. Sorry to hear. It was already answered. Looks like the MonoRail would be pretty much need a lightweight head. Any ideas for extruder? Yeah, I'm going to use the E3D V6 and with a screw mount, and then an orbiter version 1.5. Thanks. The forums were fun. I loved it. As I like to say, oops, good to have you back anyhow. Yeah, don't worry about it. Nothing's off limits question-wise. I just thought you should get maybe some of the backstory if you're still here in this video. So yeah, here we go. Have you tried the drive from a 3D pen for a lightweight extruder? The orbiter is going to be so light that I don't think we need to like get any lighter. So I think we're good. Where do you find an invite link to the RepRap Discord? If you have my email, you can just email me and I'll get you it. It's my first name dot last name at gmail.com. I'll make sure I get you a link. So anyways, that's the end of the questions. So I'm gonna see if I can disconnect here, and if I lose it, I lose it, and that's it. But I'm gonna go take you on a Testing. Okay, I lost my microphone for a second. I think it's back. Okay, prepare to get dizzy. I guess I should show you guys. This is the wall outside my room. My wife designed this Hello World installation, and these are 3D printed with ones and zeros, and there's raised patterns with the ASCII code for the actual letters, so that's pretty cool. So we got that, the effector. Can I get it off? Nope. And I don't know if anybody remembers the table bot, but there's the remnants of it. And then my school asked me to print a bunch of personal protective equipment, and of course nobody wants it, but I did what they wanted me to. So here's a bunch of arms and stuff and random parts. And then I printed fast, so they don't look great, but I printed those are my carriages, and so everything's ready to get bolted together. I have this board right here where the carriages can go right into some holes, and I can bolt right down to it, and I can get a good feel for how everything's gonna work. All right, and I guess I can show you that Wheelios is over here taking a nap. Got a t-shirt dryer, and I got a graveyard. No, this isn't a graveyard, but I got a crap ton of Monoprice mini selects. Those are student printers. They take them to their room and do work. Whenever I teach a class that uses them. This is a massive printer that needs to get a little retro. I need to fix it up a little bit so it works again. But one of my kids made that in one science fair. He's pretty proud of that. So, anyways, and I'm so busy that I have a Form 2, but I haven't ever actually connected it up. So I think I need to find time for that. All right, well, I'll take a last look at the questions, and I'll probably sign off here. Oh, my kids are on here now. We're back. Got it. Okay, your sound is back now. Good. Nice. Kudos to your wife. So much room for activities. Do you sell t-shirts? Yeah. That's the best fundraiser ever. If you ever need some money, if you're like a teacher or something like this, you can sell them for $10 a pop and like buy them for like $2.50 or so. So the and if you can print them yourself, it's the best. Damn, where do you need to go to get taught by you? Sounds like a blast. You need to be a teenager in Arkansas and have a desire to learn. I teach at the Arkansas School for Mathematics, Sciences, and the Arts, if you're wondering. Imagine making a 1 square meter volume printer and giving it away. Let's see, thanks, but it seems the message with links is retracted for me. Are the arms gonna stand up to 250C? Okay, that's a good question. Like whenever you have, I'm printing everything in PLA, but people are worried that maybe things will get too hot and they'll melt out. But the cold end of a hot end doesn't get hot enough to mess with PLA, so not a problem, especially if you have a fan on there. So no problem. If you want to change any part out, you can change the effector out to ABS or something instead of PLA. But again, PLA is the most rigid of all the materials that we can print, and anyways, it's the way to go. Can't wait for Murph. Yes, I hope it happens. I will. If most people in the U.S. can get vaccines easily by that time, I'm in. All right, probably YouTube protecting. You can use a t-shirt printer to print PCBs as well. There's a few. Oh, that's cool. Yeah, you can do so much with screen printing. I love it. I would like a Seward t-shirt with monopole. Yeah, that is the best name. Browse the public servers in Discord. Search for 3D printing. It's the one with the blue benchy. Yeah. If you make a RepRap Simpson shirt, I'll buy it for $25 or more. Oh, I have a design that says Rip Crab. Let's see if I can even find it. Let me Google this not Google it, but Rip Crab. Oh, I lost my screen share. Well, anyways, but yeah, there's we messed with the RepRap logo a little bit and turned the little teardrop guy into having 3 legs coming out of it, and then wrote Rip Crab underneath it. And I love that shirt. I have so many holes in it now. I need to make more. Sorry, I'm late. You're fine. And if this has been asked, would the arms be better as a fork design instead of a cantilevered? Okay. Yeah, nobody asked about this yet, so that's a great question. So I don't have the arm anymore, but the arm is what's called a single shear connection, where you can like cut with one plane, and the arm will cleave off, and you'll have 2 arms. So like one shear line. So yeah. So that would be called single. The way I'm doing it's called single shear, and you can do better by doing a double shear, where you actually connect. It's like you have one arm go around the other one, and that would have better performance. The disadvantage of a double shear is that you don't have the same range of motion, and so if you want to, anyways. I'm just not worrying. I'm just designing everything else to be rigid enough with a single shear, and hopefully that's good enough. If I have to go to a double shear, I will, but I think I can solve the problem other ways and stick with a single shear for simplicity of assembly and clearance issues. I have an Ender 3, so this idea is genius to me. All right, thank you. How do you feel about string-based array list in C languages? Well, Isaac Lizard King, I think if your teacher asks you to do an array list assignment, I mean, it's in the title that you should use arrays to do it. You shouldn't use a string to store all your numbers, because then you're going to spend all your time parsing instead of just being able to do random access to things. And then, anyways, it's not a good idea. I don't suggest it. If you guys don't know, Lizard King is one of my students. I like to 3D print my t-shirts. That's interesting. I think I've heard somebody do stuff like that. But yeah, I could possibly 3D print right on the screen. PLA is especially comfy. I am so glad people suggest monopole instead of polio, or I don't know how to say that. Where do you buy some shirts from you? Want to support, and I love your work. I'll tell you what, I will set up a t-shirt shop, and I will get that happening. It won't be quick. 1 a.m. Thanks for staying up. That makes sense. I don't know what makes sense, but awesome. LOL. Okay, how about a monopole Stewart? I think you mean Stewart platform. So a Stewart platform is one of those platforms with the six linear actuators that can control a full 6 degrees of freedoms. Can I make a monopole that can also do 6 degrees of freedom? Is probably the question if I had to guess. And is that possible? Maybe. I'd have to think about it. I mean, yeah, anything's possible. Is it going to be possible without arm collisions and all that stuff? Yeah, we'll have to think about it. As handsome as you are, please show the device moving around. I don't have it. I wish I did. I will get videos of it. Oh, I know what you're saying. You want this? I don't have the screen on there. Let me add it. Let's see, video capture device. Okay. Thanks for the dig. Okay. Okay. When she school asked for PPE, and you should have printed. Yeah. Okay. Yay for t-shirt shop. I can't agree. I can't agree more. Yeah. How much weight can the center platform hold? I don't know, but enough. We'll just design, I'll make arms thicker until it can handle what I need. The 3D printed t-shirt comment was a joke, but it was a YouTuber, RC Life, who 3D printed onto a shirt. Yeah, I've seen 3D printed on a shirt, but I've also seen people 3D print onto the screen itself as a way to block the ink from coming through. You know, it's easy enough to vinyl cut and then apply the vinyl. So anyways, I'm at the end of the comments. I think I will call that. I mean, I'm at 2 hours, so I'm going to call it. So, done with questions. Thank you guys so much. This has been so much fun. So, anyways, I hope to have an update soon. But you know, I have a day job, so enjoy this for now. Something stupid.